This is for question 9 from Year 11 methods. We're going to look at exercise 5b. So we want to sketch the graph of the following, stating the maximal domain range of each of the following. Now the word maximal just basically means what's my natural domain and range of these graphs, okay? So natural meaning I haven't placed any restrictions on what the graph can be, okay? Like what values the graph can take, basically. So it's not being cut off. If it was to express itself in its natural form, what's the domain and range? Now, if you look at part A, we've got x equals y squared. If I take the square root of both sides, I get plus or minus root x equals y. Now, this is actually a parabola on its side. Okay, it's like two root graphs together. So the first root graph will be root y equals plus root x, which is just the normal root x graph, and minus root x, which means it's a reflection of it. So we have it upside down, not upside down, but side-on parabola. So the graph starts at 0 for the domain. My domain, it'll go start at 0, and it goes on forever on this side, okay? So it'll go to infinity. My range, and I want everyone to think about this. Can you see the graph goes on forever at the top? Okay, it'll go on forever at the top and go on forever at the bottom. So it'll be negative infinity to infinity, which in easy terms, it's reals. Part B, it's a similar type of graph. X squared equals y squared plus 1. If I move the 1 to the other side, if I move the 1 to the other side and I square root it, I get plus or minus root x plus 1 equals y squared, or equals y, sorry. So it's a root graph again. We've got two pieces. We've got a plus piece and a minus piece. The root graph has been shifted one to the right. So you're starting here at 1, you got two pieces, first piece and bottom piece. So the domain of this graph would be from 1 to infinity. My range would be from negative infinity to positive infinity, which is all reals. Okay. C, got something similar. So if I move the 1 to the other side, I get x plus 1 equals y squared. Y equals plus or minus root x plus 1. Okay, so the graph has been shifted 1 to the left. So now it looks like I'm just drawing, oops. Let's go back here. I'm just drawing this really roughly. So it's a side-on parabola again, but except your turning point is at negative 1, 0. So my domain would be negative 1 to infinity. My range would be all reals. And D, if I move the x to the other side, y minus 1 squared. So if I square both sides, I get plus or minus x minus 1 equals y minus 1. What's happened is that I add 1 to both sides, so y equals 1 plus or minus root x plus 1. So the graph has moved 1 to the right and 1 to the right and 1 up. Okay. So the root x graph has moved 1 to the right, 1 up. So it will look something like this. Oops. It's a very good. Trying to get this to look a bit better. So it looks something like this. We've got a turning point at negative, not negative 1, 1 and 1, 1, 1. Okay, it's going to look like that. It's going to go forever that way and that way. So your domain would be from 1 to infinity, and your range would still be reals, okay, because it goes up forever up the top, like that, and down forever down the bottom, okay. So hopefully that helps, okay, and I think the real trick part is knowing what these graphs actually look like, because I know it's a bit confusing when you have x equals something rather than y equals something. Just rearrange it to make y equals something, okay. Hopefully that helps.